Greetings to everyone. This is Earl Brian A. Roble of the Junior High School Department of Regional Science High School for Region 9. This lecture will be part of the Performance Task Lecture Series on Computational Chemistry and Enhanced Science for Chemistry. In this lecture, we are going to discuss balancing chemical equation, specifically photosynthesis, as an example using matrix algebra and least common multiple, or as I call it, it's Earl's method since I was the one who devised and came up with this method in balancing chemical equation. Here we start with the law of conservation of mass. According to Anton Lavoisier, matter can neither be destroyed nor created. This is a simple law and fundamental law in chemical reactions. The law of conservation of mass can be translated into mathematical sentence or equation. So what we can see here is the Earls Principle on conservation of mass in a chemical reaction. This is Earls Principle since I was also the one who derived or translated the law of conservation of mass to mathematical equation in the context of chemical reaction. We will not dwell much on this since this concept, we will discuss this later and we will use this to understand balancing equations using Earl's method. The equation of photosynthesis. So we all know that photosynthesis is the process used by organisms with chlorophyll to convert light energy into chemical energy that they can use for cellular respiration. So the simple equation of photosynthesis can be written as carbon dioxide plus water with the help of chlorophyll and sunlight yields glucose and oxygen gas as a byproduct. However, this simple equation is not balanced. So let us check. From here, we can check if this equation is balanced. An equation is said to be balanced, or a chemical equation is said to be balanced when the sum of atoms on the reactant side is the same or equal to the product side of the reaction. And let us check the reactant's side. Carbon is equals to 2, hydrogen is equals to 2, oxygen is equals to 3. Meanwhile, on the product side, carbon is equals to 6, hydrogen is equals to 12, and oxygen is equals to 8. So clearly, this reaction or equation is not balanced. So should we do the trial and error to balance this equation? Well, I guess no, because our main goal in this video is we will not use trial and error method. So we will use what we call Earl's method. Earl's method uses matrix. So if you're not familiar with matrix look like this bracket containing different numbers arranged into arrays. So this is linear algebra in which you can encounter this when you reach college. So we write the corresponding number of atoms of a specific element in a compound for the reactant side and product side inside the matrix. So this one corresponds to the 1 atom of carbon, 0 corresponds to the 0 number of atom in this compound of hydrogen, because there's no hydrogen here, so it's 0. Oxygen 2, and so as for water it follows. And for the product side, see here that 6, 12, 6, and 0, 0, 2, because there's no carbon, hydrogen, and oxygen gas. So we give a unique identifier for every space in this matrix denoted as C sub 1, C sub 2, C sub 3, and so on. So this R1, R sub 1, R sub 2 represents to the first column and second column of the matrix of the reactant side, and so as for the products side. This will be useful later on as we try to break this matrix into pieces. Step 1 in Earl's method is find the LCM of the number of atoms in each compound. So that one, the R sub 1, R sub 2, P sub 1, and P sub 2. So for carbon dioxide, that is located on our first column, it's the LCM of 1 and 2, which is definitely 2, and same as for water, since uh, 2 is a multiple of 2 by itself, and 2 is also a multiple of 1. So there's no problem here. For the first compound in our products side, which is glucose or C6H12O6, we need to find the LCM of 6, 12, and 6. This is also easy since uh, 12 is divisible by 6, so 12 is the least common multiple of 12 and 6. So it's given. And for oxygen, so there's no other element that is present on the compound oxygen. So we just put here the LCM of 2 is 2 itself. Step 2 is that we solve the nested LCM using Earl's balancing formula. So this is the balancing formula that I derived to find the coefficient A for each compound. So we need to add coefficients here since we cannot change these subscripts or the number of atoms. So we can just add coefficients here to make this equation balanced. So where R sub n is the specified reactant, which is a compound, and so as for P sub n, which corresponds to product. Rc is the LCM of the reference compound. Sorry, this should be reference, not reference. So we already had that earlier for all of the elements or compounds rather here, the carbon dioxide, water, and so on. A sub Rc is the coefficient or the thing that we're trying to find in this formula. So we have to solve now for the coefficient of carbon dioxide. So it's a nested LCM, LCM of 2 and 2, and LCM of 12 and 2, and find their LCM. So LCM of 2 and 2 is 2. LCM of 12 and 2 is still 12, because 12 is a multiple of 2 and 12 is multiple by itself also. So the LCM of 2 and 12 divided by 2, which is the number of which is the LCM of the compound carbon dioxide. So the least common multiple of 2 and 12 is 12 divided by 2 gives us 6. Hence, therefore, our equation must look like this. So the coefficient for carbon dioxide must be 6. Next, we solve for the coefficient of water. So we need to jump now because we already know that the numerator of our formula is 12 because the least common multiple of all elements in our reaction is 12. So just divide it by 2, which is the LCM of the number of atoms in water. So 12 divided by 2 is still 6. So our equation is now taking shape. So our equation must look like 6CO2 plus 6H2O yields glucose and oxygen. So still similar process, we just repeat, but we just change the denominator here since the LCM of glucose that we have derived earlier is 12. 12 divided by 12 is 1, so we don't need to add 1 here. So it just simply like that. It's already understood that there's 1 here in this part. Last, we solve for the coefficient of oxygen. So it's just a similar process since LCM of oxygen is also 2. So 12 divided by 2 is 6. Now our balance equation is complete. So the balance equation for photosynthesis is 6 carbon dioxide atoms or molecules plus 6 water molecules yields 1 molecule of glucose and 6 molecules of oxygen. So here's a tip from me. Earl's equation should perfectly work on all chemical equations. So it's a generalized formula for all chemical equation. If you're not familiar with LCM algorithm, it's here. You just need to do the math. If you're not into math, then I suggest you must do math because chemistry involves math, and for greater or bigger numbers or quantities in the equation, then you really need to solve for LCM. Anyway, LCM is an easy topic. It is, it was discussed on my elementary days. Thank you very much and have a scientific day.